This is number 8i. We have to differentiate this. We have to find the first derivative of this function. So this is actually a question of implicit differentiation, right? So we should be conversant with the concept of implicit differentiation. If you are not, please source for materials around that topic so that you can get clarified. I won't be able to go into much details on the process involved in implicit differentiation, but I believe you should be able to pick out one or two things from this, from this example. Alright, so as a rule of thumb, whenever you're differentiating y using implicit differentiation, you always have to attach dy dx. Okay, so we have y square here. So let's differentiate y square. If you differentiate y square, you're going to have 2y, okay, 2y dy dx. Remember, I said whenever I differentiating y, you have to attach dy dx to it. So let's work on sine xy. Okay, let's work on sine xy. So I'll do it separately. Right, so let me differentiate sine xy. I'll do it separately here. So there are so many things going on in sine xy, so you have to be careful so you don't make mistake. First of all, let me use chain rule. Okay, let's chain rule. So we can say that let u be equal to xy. In that case, we should have sine u. Okay, this should be sine u because we have replaced xy with u. And that means, according to the chain rule, if we say this is y, let's y be equal to sine u. Okay, we can say that dy dx. Remember, we are trying to differentiate sine xy, so dy dx will be equal to dy du times du dx. Okay, and what's dy du? Simply means differentiate y with respect to u here. And if you do that, you should have cos u, okay, times, and now if I differentiate xy, so I'm going to differentiate implicitly, but this is also a problem of product rule, using product rule to work this out. So if I use product rule to work this out, I should have x dy dx plus y. Yeah, so this is what you're going to have. So let me put a bracket here to indicate that because you're multiplying everything here. Okay, in that case, remember that u is equal to what? Xy, so we'll just replace it. So we have cos xy, oh no, cos xy into x dy dx plus y. All right, so I can simplify this further. To do that, I have to use cos xy to multiply everything in the bracket. So I start with cos xy times x dy dx should give me x cos xy dy dx plus cos xy times y is y cos xy. All right, so I've simplified that. Now we know if you differentiate 3, it's going to be 0 because the constant is 0. So what do we have now, since we have finished differentiating each of these functions one after the other? So what I have left is going to be 2y dy dx. I believe you know where that is coming from. We've done that here already. Plus, when we differentiated x sine xy, we had what? This is what we had. So that means we can replace it to be x cos xy dy dx plus y cos xy. Remember, when we differentiated 3, it became 0, so this is equal to 0. Now the next thing we have to do is to factorize. That's group all the dy dx's and factor dy dx out. So if you observe, I have a dy dx here, I also have a dy dx here. So if I factorize it, I should have dy dx into, if I remove dy dx from here, I have 2y left, 2y plus, if I remove dy dx here, I have x cos xy here left. All right, equal to, so I take this y over to this place, this y now to this other side of the equation, becomes negative y cos xy. So I divide both sides because I'm trying to look for dy dx, so I have to make a subject of formula. I divide both sides by 2y plus x cos xy rather, and I should have that dy dx is equal to negative y cos xy all over 2y plus x cos xy. And that should be my final answer.